All right, so here we are. And you practiced, I hoped, and we're going to see how it turns out. Now remember, the whole purpose of this is to get rid of the fractions. So the first thing we need to do is look and see what our denominators are. So this one has an 8 and a 4 and a 4 and a 16 and none. So we are going to put a 1 under this because whenever you don't have a denominator, it's really a 1. And then what we're going to do for the next step is to look for the common denominator. So let's look at the 16 because that's the biggest number. Can all of these other factors make a 16 when you multiply it by something? Absolutely. So we're going to use 16 as our common denominator. So 8 times 2 is 16. So we're going to do 2 on the bottom and 2 on the top. 4 times 4 is 16. So we're going to do 4 on the bottom and 4 on the top. Another 4 times 4 on the bottom and 4 on the top. So now I have 16, 16, 16, 16. I need this one. Don't forget this guy. We need to make a 16 on the bottom and on the top in order to create an even playing field. Once every single term, every single one has the same denominator, we can rewrite the numerator and solve the equation. Remember, we're not just rewriting the top. We have to rewrite what we get after we make the equivalence fraction. So this is really 2 times 7, not just 7. So 2 times 7, this is going to be a 14x. This is a negative 1 times 4. That's a negative 4. This is a positive 3 times 4. That's a 12 with an x. This we didn't do anything to because this was already 16. So we're just going to put the 1. And then x times 16 is 16x. So fraction's gone. We're going to do a little cleanup on the left side of equals to get our common terms together, combining our like terms. So we have a 14x and a 12x, and we're adding them. That's going to give us a 26x. Bring down our minus 4, and we have 1 plus 16x. We're going to solve this by getting all of our variables on one end of the equal sign. So I decided to do additive inverse for 16. I'm subtracting the 16. I'm going to bring that one down. 26 minus 16 is 10. Bring down that minus 4. Then I'm going to move the constant by adding 4 to this side. These cancel. I get 10x equals 5. Now I want you to stop right here because we are getting x by itself. What prevents x from being by itself? The 10. 10 is what gets divided. And you got to be careful with this. 10 divided by 10 is 1. So cross that out, get x. And 5/10 is not 2. 5 divided by 5 is 1. 10 divided by 5 is 2. It's 1/2. Okay? So that's your first one. So hopefully you got 1/2. If you got all the way to the bottom and divided both sides by 5, that's not true because you're trying to get x by itself. So you got to move the 10. All right? And here's our second try practice. And this one's a little different than the ones that we've practiced before because the biggest number is a 4 and the 3 can't make a 4. So what are you going to use as your common denominator? Well, if you don't know, multiply them together. You get 12. So this one should have a 4 on the bottom and the top. It's going to give us 12. This 4 needs a 3 on the bottom and the top. That's going to give us 12 on the bottom. And this 3 needs a 4 on the bottom and the top. That's going to give us 12. So this is 12, this is 12, and this is 12. Now that we have common denominators all the way through, we're just going to rewrite our numerators and solve the equation. So 4 times 2 is 8, plus 3 times 1 is 3 with the x, and 1 times 4 is 4. Boom. So close to being done. We're going to subtract our 8 because we need to get our x by itself. When we move our constant over with its like term, we get negative 4. And we are dividing by 3. We got to get x alone. So we're going to divide both sides by 3. And you're going to leave this alone. This is the answer. Negative 4/3 is our final answer. Don't change it to a decimal. That's done. You don't even need to change it to a mixed number. It's done. Be happy with it. All right, we're going to move to the next slide and do a couple more, and then we're done for today.